we doing? How are we doing? Come on, last session of the day, y'all. Let me hear you. Right. right. Absolutely. Absolutely. Y'all, the moment y'all been waiting for. I feel like y'all love him more than me, but that's okay. But that's okay because I'm okay sharing. Y'all, we have the next speaker, our last session of the day. He needs no introduction, but I'll give one. Rami Abdu is ColorStack's head of engineering and a Cornell University grad. Me too. Hey, what is it called? Cornellian, period. Cornellians, hey. He's developed ColorStack's open source software, including the Opportunities Board, Offers Database, and AI resume review tools. Today, he'll share something special on building a RAG system, RAG system, to help you think big and bright about the future. Y'all already know the commotion in the chat, the commotion in the emojis. Give it up for Rami.
Appreciate you guys. Thank you. Happy end of the year, y'all. It's crazy. We made it to the end of the year. I'm beat personally. I'm ready for this break. I'm moving in 2 days back to sunny California. So shout out to Seattle. You did your part, but it's time to move back home, close to the fam, back to the sun. Paying 9% taxes for the sun, by the way. What is this? This is ridiculous. Nah, but just overall a great period. We got to reflect with the team on what we've done at ColorStack this year, and I hope y'all are proud of us, man. We've done a lot of stuff this year, from the summit to oyster things to just a bunch of events for you guys, and it's been pretty special. So it's definitely kind of a reflection period. But even at the end of the year, we're still doing exciting things. If you haven't seen, we're doing a winter break hackathon, so I'll tell you guys just a little bit about that, just in a second. And then what I really want to do for you guys, I haven't done like a technical deep dive in quite a long time. I think the last time was maybe a year ago, or like sometime way long ago, about webhooks and teaching you guys about that. So hopefully we'll be just be able to talk about some more technical things. So I'm gonna share my screen here right now, and let's get into it, man. Let's get into it. Tip, I know, I stopped my screen on purpose. Don't worry. So the title of today's session is how to build a RAG system. A lot of you were saying, what the heck is RAG? Don't worry, we'll get into it. Again, before then, I just want to make sure every single person here knows that we officially are underway with our ColorStack Winter Break Hackathon. If you haven't actually seen this Notion page, I'm gonna share this screen really quickly. This is pretty much just like your guide for everything you need to know about the Winter Break Hackathon, starting today, ending Friday, the 10th of January. You can work on teams of up to 4. You can also work solo if you want. You can literally build whatever you want. Honestly, our biggest motivation for this hackathon is like, if you were like on the brink of like, oh shoot, I might want to build something this winter break, but I don't know, I just, I'm not 100% sure. We just want to be the push for you. That's literally it. Like, you don't have to approach this like some crazy hackathon. We literally just want you to build and learn over the break. If you have free time, of course. I know a lot of people are spending time with fam, maybe traveling. That's still 100% is the most important thing. But if you're, I've seen a few messages already that's like, I'm kind of bored. What should I do? We're gonna push you, to learn and build. So pretty much everything you need to know is here. We got 5 different categories. I think it's like potentially up to like 2,000 in prizes. We're not here to like give out a bunch of money. We're just here to make you want to build. That's literally it. So if you haven't checked out that Notion doc, please do. So that's that. Oh shoot, drum photo. Hey, Bessie, that's crazy. Cool. So that's that. We have a winter break hackathon channel, by the way. So just over break, this is where you guys should be just building community like you do in literally every other channel. Again, this is not some like super competitive thing where it's like, oh shoot, one team has to, be super secretive. Honestly, we want you to share as much as possible. We want you to help each other as much as possible. And again, like just make sure you treat every ColorStack member like a ColorStack member, like how you always have. This is a very collaborative thing, and hopefully just something a little bit exciting for everyone. In case you wanted to jam over the break, I want to highlight this thing that was in the Notion page that some people might have quickly looked over. And it says any team that chooses to continue working on this project in the future and makes their project open source, not necessarily accepting new contributors, but ideally accepting new contributors, ColorStack will help cover their hosting and infrastructure costs for the year. Okay, and the main reason is we want you to keep working on your project. I dropped something in the Oyster channel. If you're not in that a little bit earlier, that just was talking about kind of our shift, and like we unfortunately cannot meet the demand of everybody in ColorStack wanting to contribute. I am a one-person team. Tomas is also working part-time. It is quite a bit for us to manage. And what we realize is that like there's so many very very talented people in ColorStack that like could literally do the same thing. And like if we just hammer down the note of community, which is literally in every aspect and fiber of what we do with ColorStack, then like we can actually scale this a lot more reasonably. So just a note on that, that this is something that we will encourage you guys to keep working on in the future. If you have any questions, put them in the Q&A. We'll get to it hopefully at the end. Okay. Cool, cool, cool. So let's get into it. Let's get into the technical chops, man. These are personally my favorite sessions. Anytime we go to like a conference or like some sort of event, I'm like, let's talk about some technical things. I don't want to talk about other topics. Let's get into the meat of things. So RAG, what is RAG? Retrieval augmented generation. That sounds mad scary. Okay, that sounds mad scary. It sounds like, yeah, like that's for the research papers. We're not really gonna touch that. It's really not that crazy. I'm gonna explain to you what it is. This is gonna be the 101 on how to build a retrieval augmented generation system. Crazy. It sounds it's a mouthful. What is RAG? RAG is simply just a way to ground an LLM's response in some additional data or context that you have. Okay. What do I mean by LLM? You guys have all used ChatGPT or Claude or in Perplexity, all these different AI systems, these LLMs, large language models. You can ask them anything, and they've trained on just a bunch of data that's just out there, and they can respond based on that data. Now, the thing is, they don't necessarily have all the data in the world. For example, in ColorStack Slack, they don't have access to all of the LLMs weren't trained on ColorStack Slack's data. If you're asking like a specific question about some sort of private data, just more generically, it's not going to be in the LLM. The LLM does not know that, and so retrieval augmented generation is just a way to say, hey, we have some data that I think the LLM can use, and we want them to use it in order to format this response. Okay, so that's pretty much all it is. Nothing crazy to it. There's a really good graphic that Google put out, so I just want to use it. I don't want to build this from the ground up. Pretty much just imagine a scenario where somebody's asking when and where is Taylor Swift's next concert, right? And so, oops, sorry about that. When and where is Taylor Swift's next concert? And so the prompt into the LLM is pretty much just that. We might tell it, hey, you're a helpful assistant, try to come up with this answer. It goes to the LLM, and then it pretty much says, I don't have access to real-time information, including concert schedules, blah, 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 blah. We've got this response multiple times, right? It says, oh, I don't have real-time web access, I can't search the internet in real time or anything like that. That's kind of a bottleneck, right? Like, in order to answer this question, we do need some live data, and the LLM is not trained on, for example, if Taylor Swift literally just drops a new concert tomorrow, the LLM is not going to know that because it wasn't trained on that type of data. Okay, and so the big difference with retrieval augmented generation is just one simple step, which is for us to actually retrieve some meaningful data. So if we're doing this manually, this might look like doing a Google search, and then in Google I find Taylor Swift's concert tour, and I see based on that she has a few of these concert tour dates. I'm sorry. And so then now when we pass this into the LLM, we just say, hey, ground your response in some of these facts. She's touring in 2 countries. She has 18 upcoming concerts, yada, 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 right? And so now the LLM, even though it wasn't trained on that data, it can now take in that data and actually come up with a meaningful response and format it in that very, very refined way that LLMs do very well, right? And so now it comes up with the response of Taylor Swift's next concert is on October 18th, yada, yada, yada. Okay. So really all this is just saying, hey, take some additional data and then LLM do what you typically do. Okay. So that's kind of that. It's actually very, very simple and it's very, very powerful. You can use this in a bunch of different ways. So I want to just compare two prompts. If we just ask, for example, ChatGPT right now, if we said, has anybody in the ColorStack slamp, I'm getting all mixed up with my words. Has anybody in the ColorStack Slack done the ramp away? Okay, if we ask ChatGPT or Claude or any other LLM that question right now, what is it gonna say? It's gonna say something to the effect of, what the heck is the ColorStack Slack? I don't know anything about that. I don't have access to any of that data. I don't have real time, web search abilities, whatever it's gonna say, right? Obviously, it's not gonna know anything. Now compare it with this second prompt. Has anybody in the ColorStack Slack done the ramp away? And then subsequently on 8-1, somebody said it was conducted on code signal. On 12-23, somebody said it's a 4-part design system problem. On 9-4, multiple people said it was really difficult. Whatever, right? This is data that, as a ColorStack engineer, we have this data in our database. So I can just pass this to the LLM and say, hey, all these things happen. Now come up with some response. And the result now is we can actually have a meaningful response based on our own private data, right? Based on the ColorStack threads, here's everything you need to know. The OA is conducted on this platform. It's a 4-part design system. You typically need a score of 600, and it has all the sources that we passed into it. Okay, very, very simple difference, which is just, again, passing some additional data, and now it's coming up with this beautiful summary that we wouldn't be able to do ourselves, right? Again, utilizing the LLM for what it's really, really good at, and what it's not really good at, we're just supplementing with some additional context. So that's that. Okay, cool. Um, let's just break down each letter, right? Retrieval, augmented, generation. Retrieval is really just a fancy word. Well, retrieval is not that fancy, but you see what I'm saying. It's really just saying, let's just search for some relevant data, right? Like, we know how to, based on the context, as the engineer, we're gonna know how to search for that data, whether it's in our database, whether it's in somebody else's database, whatever the case, we're gonna be searching for some relevant data. Augmented just really means whatever that data is, pass it into the LLM. Okay, it's just augmenting. It's just saying, hey, you have this existing thing. We're gonna just augment some additional things on top of it. Generation is what we already use the LLM for. LLMs generate a response, except now it's just gonna be grounded in that data that we passed in. So it's like really, really simple. It's, if you actually break it down, our role in implementing RAG is really just the R. Okay, so if we go back to this, it's really just the retrieval. That's really all we have to care about. The generation the LLM is going to do. There's obviously some safety, kind of things to look out for there, and just making sure that we're keeping things private and things like that. But retrieval is really our main focus. We pretty much just need to retrieve some data to give to the LLM. Okay. So I want to just talk a little bit about retrieval. I'm actually gonna like just mention really quickly that like this retrieval step is not like necessarily this like new phenomenon in AI that's like, oh, now this retrieval. Really, all it is just semantic search, which has been around for many, many moons. Semantic search is pretty much just saying, how do we retrieve the data that we want based on language and semantic meaning? So, for example, if I'm asking a question like, has anybody done the ramp away? How do we retrieve the relevant threads that happen in Slack? Again, just based off of that semantic meaning. The same way that if I ask you a question, you'd be able to tell me, oh yeah, I remember somebody was talking about this, that, and the other, right? So how do we implement semantic search? I'm gonna show you this video. It's actually a video that Tomas shared, which I think is really, really helpful. I don't know why the example uses Hitler. Just ignore that, okay? But it's actually pretty helpful in terms of understanding how semantic search is typically happening. So let's I'm gonna check in the chat if you guys can't hear this, but yeah, here we go.
What is Hitler plus Italy minus Germany? This came up in a full video that I did dissecting what happens inside large language models. You see, when tools like ChatGPT process text, the first thing they do is subdivide it into little pieces, and they associate each piece with a large vector, some long list of numbers. This is called an embedding of that piece of text, and it's helpful to imagine these embedding vectors as directions in some very high-dimensional space, even if we struggle to concretely visualize anything more than 3 dimensions. Models that learn to embed words as vectors like this often encode meaning into the directions of this high-dimensional space. If you take the difference between the embeddings of man and woman, and you add that to the embedding of uncle, you get a vector very close to the embedding of aunt. If you take the embedding of Italy minus Germany and you add it to the embedding of Hitler, you get something very close to the embedding of Mussolini. It's as if the model learned to associate some directions in this high dimensional space with Italianness and others with World War II Axis leaders. What is
Sorry, my bad. Some of y'all are funny in the chat. Yes, you should have paid attention in linear algebra because if you break it down, a lot of AI and machine learning is pretty much just linear algebra. That's why they say in that class. If you're gonna do this, you probably understand some of the underlying things happening in AI and ML. So yeah, so that hopefully you guys kind of got that like visual representation. I was like trying to do something in a slide, but I was like, I'm not gonna be able to like do all this like visual stuff. So I was like, you know what? Let me just share this video that Tomas had sent. So if we look at it, embeddings are literally just a way to represent text as vectors or essentially just numbers, right? Like it's just putting some numerical value on text, which sounds weird. But if you think about it, we all know how to calculate the distance between 2 points, or at least at some point in our educational journey, we knew how to calculate the distance between 2 points. So if we kind of just look at it this way, you take some text, you take an image, a video, whatever, something like what is the ramp away like? It goes into this embedding model, which is again, has some of the AI and ML magic happening behind the scenes, and then it spits out some vector, right? It's just an array of numbers essentially. And those numbers kind of represent some meaning. Again, we don't know the magic that happens in the kind of embedding training and how they do that. But the important thing for us to understand is that it's just some numerical array. And again, if we have two arrays, we know how to calculate the distance between those 2 points. Cool. Um, Now that we actually understand embeddings and like have embeddings, the same way that we store any other data, right? So anything that happens in your application, you're storing as data. We also need to store embeddings, right? And it's going to be a little bit separate. There's some specialized databases for it. So pretty much if we want to implement semantic search, we need to actually store our embeddings somewhere. If you've ever heard the term vector database, that's what a vector database is for. Okay, it's you have all these very, very high dimensional vectors, and we just need to store them somewhere. These dimensions can go very, very high. It's like working in crazy high dimensionality spaces. So it actually needs some sort of specialization. You can't just like put it in, kind of try to shoehorn this into any of your normal databases like Postgres or MySQL or whatever. Even though some of them are starting to develop extensions for them, there's some very, very specialized vector databases that specialize in how to deal with these very large numbers and vectors. So I actually want to just walk you guys through a full example of like Ask ColorStack AI, which is in the member profile. And I just want to like walk through how pretty much that works, right? Based on everything that we talked about. So every time a Slack message is sent, we store that in our own database, by the way. So anything that's sent in a public channel, we have webhooks that are listening, and we store that, which allows us to render that in the member profile and some other places. And so every time a Slack message is sent now on the AI side, we essentially create an embedding of that message. Again, we use OpenAI's embedding model. So we pass in that text, it spits out some vector or embedding. And then we store that embedding in a vector database. In our case, we're using a vector database called Pinecone. There's some other really popular ones out there, but that's the one that we're using. So that's happening as every Slack message is sent. The threads are getting updated. These embeddings are getting updated. So if somebody's asking or talking about the ramp away, for example, somebody that responded much later in that process, that's some like very meaningful information. Every single time that thread is updated, we're actually updating the corresponding embedding or vector that represents that thread. And so that's kind of step one. The next step is when you actually ask a question to the ColorStack AI. We first again create an embedding of the question. It's just a way for us to understand the semantic meaning behind that question, and then we pass that. The second step, we pass that embedding to our vector database to find the most similar vectors. Okay, so a lot of times when you're interacting with these vector databases, pretty much the input, if you're querying for similarity and semantic search, you literally just pass in some vector, and it's pretty much just going to tell you, hey, these are the most X similar vectors. And in our case, we're using the five most similar vectors that correlate. And so like it might actually come up with things that aren't the best. So like if somebody asks, oh, how was the ramp away? sometimes it can say like, oh, how was the Slack OA? It might come up with that in the vector embedding, in terms of similarity, if there's not any other better matches. So that's just something to keep in mind. Once we actually get those 5 most similar vectors, again, these are just numerical representations. So like obviously, like if we pass that to a large language model, it's going to be like, what the heck is this? It's not going to know what the actual data is. So now we need to actually fetch the actual records from our database. So for example, we have Slack messages. Those are stored in our database. We also have embeddings of those Slack messages in Pinecone. And so now once we get those 5 most similar Slack threads, we're going to actually fetch those Slack threads from our database, aka Postgres, that correlate with those vectors. And if you're wondering, oh, how do you correlate vectors to your actual database? You can actually store metadata on every single vector that goes into the vector database. And so, like for example, and it's just a way for us to reference like and keep track of like, okay, what the heck is this random vector? Oh, it's the vector that corresponds with Slack message ID this and Slack channel ID this. Okay, so it's just a way for us to essentially link vectors back to the original records. And then after that, we literally just format the data and pass it into the LLM with whatever your prompt was going to be. So in our case, when you're using Ask AI in the member profile, what we're really doing is having this long prompt that says, hey, we have Slack messages. Try to answer this question based on the provided Slack threads, and then we'll actually provide some formatted Slack threads that are the most similar, if that makes sense. Um, I know I'm rambling and I'm talking quite a bit, but hopefully you guys can kind of understand that. I want to actually go through a code walkthrough. I'm personally a big visual learner. I love seeing code just in general. So let's go ahead and actually look at some code. And then, oh wow, I'm actually breezing through this Prezi. I didn't realize. So we're actually gonna have more time for Q&A, for sure. But okay, cool. So what I have here, I just kind of this is not like the production version of what we do. I stripped out a bunch of things just to make it just a tad more simpler, but like the principles are literally everywhere. In this piece of code here. Okay, so first things first. And so what we're gonna assume for the problem is that somebody asks a question and then we want to give them a response. Okay, based on our Slack messages. Okay. So again, I already mentioned Pinecone is a vector database, so we're just kind of initializing Pinecone with our API key. We're going to be taking in a question, and then we're going to be responding with just a string-based answer. Okay. So the first thing is we actually need to create an embedding of the question. Okay. So that's step one. An embedding, by the way, we just call OpenAI's API. They're gonna embed the text into a vector. Okay. So now this is going to be an array of numbers essentially. Next thing, now that we actually have that embedding, is we need to query our vector database to try to find the most similar embeddings, the most similar vectors. Okay, and so in Pinecone, it's a database just like any other one. It's a little more similar to, at least when you interact with it, it's a little more similar to like a NoSQL database, and so they kind of have these somewhat versions of these different stores or these different tables, if you will. And so we have one called Slack messages. So we're actually just going to go ahead and query, and we're going to say, give us the top 5 most similar threads. And the thing that we're going to be comparing is this embedding that we just created of the question. Okay. We're going to get this array of matches back. Okay. And then the next step now is, now that we have those matches from our vector database, we need to actually get the actual records from our database that correlate with those embeddings. Okay. And so what we're going to do here is we're literally just going to go in our database, try to find some Slack messages that have that corresponding ID. And that's going to give us pretty much the thread from our own database. Okay. And like I mentioned earlier, we have the ability to store metadata in our vector database. And so that's how we're actually able to correlate the embedding. So if I look at, this match right here, I see that has a match.id and a match.metadata.channel ID, which is that, and then also a match.id, which in our case is just the Slack message ID. So that's how we're actually able to go to our Postgres database, get the actual data from there. And then finally, this is an easy step. We just format it in a text type of format that will be easy for the LLM to parse. Okay. So first we give it the relevance score. So when we actually fetch it from our vector database, it's going to say like, oh, on a scale from 0 to 1, how similar is the embedding or the vector that you passed in to the embedding that got returned. And so it could be 0.99, it could be 1.0 if it's exactly the same. It's going to have some relevant score. So we understand how good of a match is this. We'll pass in some other metadata like timestamp. We tell the LLM if it's a really old thread, then take it with a grain of salt. Things might have changed, especially if you're talking about something like a company specific question. The actual message, and then some of the replies to that message, because a lot of important information is in the replies, especially in our ColorStack Slack. And so that's kind of what we're doing. And so now essentially what we have is this array of threads, and it's literally just this string based answer. And so we're gonna say, please answer the following question based on the Slack context. Here's the question. Here are the threads that we found, and again, it has all of this information baked into it. And then finally, it's now just sending the prompt to the LLM. So in our case, get chat completion is literally just going to Claude. It's passing in that prompt, and it's saying, do this in a limited amount of tokens. And that's pretty much going to give us right here an answer. And so now we're actually going to have some answer for the question that we have. Okay. That's pretty much it. Like that's all there is to it. Again, the really important step is just we need to actually fetch some data from our vector database, get the correlated records, and then pass it to LLM. So there's some smaller stuff here like how to create an embedding. Again, this is just the API request to the OpenAI API. That's pretty much it. And then some additional system prompt stuff that just helps the LLM ground its answer a little bit more. And that's kind of that. So we definitely have more time than I expected. So we'll have a longer Q&A session. Maybe if Jaron is free as well, he can come answer some questions. But yeah, thank you again. Happy winter break hacking. I'm really excited to see what all you guys build. It would be really dope too if you guys built some AI things. Doesn't have to be too crazy. Again, RAG is a very simple process. And yeah, that's pretty much it. So I'll go ahead and open Q&A. No worries, Dale, and good luck in that meeting. I'm glad you guys like the technical things. Yeah, hopefully we could definitely do more technical sessions in general. I'm definitely a big fan of them. I want to learn from others and things like that. So let's go ahead and look at Q&A. I think there's a few things. What are the pros and cons of a vector database? I wouldn't necessarily think about it as pros and cons. I'd say they're kind of a specialized tool. So like if this is a particular problem that you want to solve, which is storing very large dimensional vectors, then vector database is a good tool of choice. Again, there's now starting to be development in terms of like extensions. Like for example, there's a Postgres extension now called PG Vector, and then there's some actual iterations of that where you can literally just store your vectors in Postgres itself, and it has some special handling of that. So that's completely valid too. It's completely valid too. But oftentimes when we're solving engineering problems, we ideally are not shoehorning technology to make it work. Ideally, we're choosing the right tool for the problem at hand, and many times vector database is going to be that when we want to store very high dimensional vectors. So yeah. How new is RAG and how frequently is it used in the tech industry? I wouldn't say RAG is like a new idea. You know what? I would say I haven't seen it personally, and again, I'm 5 years out of college or 4 years out of college. So this could be the case that it's been used forever, but I would say I've definitely heard it more popularized with LLMs. The retrieval step 100% is not new at all. Like people creating embeddings of things and implementing semantic search. Like that's always been around. That's for pretty much as long as the web has been born. But in terms of retrieval augmented generation, I think especially because of the generation part, I think that's something that's a little newer with the rise of LLMs. And in terms of how frequently it's used in industry, like I would imagine that any popular tool that you use nowadays, if they haven't baked it into their product at some point, or in some form or fashion, it's probably coming soon. So this is definitely a popular thing nowadays, at least. And it's also like one of the simplest ways to get started with introducing AI into your company. Like, and nowadays it seems like every single tech company has AI, and so this is just a very simple way to get started with that, because like a lot of the times, and what's the most popular use case that like every single company is like, okay, like that makes sense. It's typically some support documentation, or help with documentation and finding the right answer. And so like all of these companies already have that data, and so now it's just about like how can we surface that data a little bit better. And so like I would imagine that RAG is probably the first tool that they look for there. So yeah, good question. How do you stay up to date on the latest tech? That's actually a really great question. I feel like you youngins only use Instagram and TikTok. Personally, I'm a big Twitter guy. I feel like tech Twitter is yeah, like literally almost everything I learned is from tech Twitter. So there's only two Twitters that I'm on. It's tech Twitter and Liverpool Twitter. If you're a soccer fan, that's literally like all my Twitter timeline is. But I learned a lot of stuff from tech Twitter. So like, and the really cool thing too is like all these like popular packages that you guys might be using in your day to day. Like most of them are actually like pretty active on Twitter and like talking about their work. Like one thing that was really crazy. I don't know if you guys have ever used this tool called Zod, ZOD. It's like a validation library in JavaScript. Literally, like this guy pulled up. I pulled up to this Seattle JS event, Seattle JavaScript event. He literally was there. Randomly met him, and like we ended up playing soccer together. Like a lot of these people, and the only reason I knew him is because of his talking about his work on Twitter and things like that. And so that's like definitely the place that I learned from. And then honestly, this makes me really proud personally. But a lot of places I learned about the next best place where I learned about new tech is in the ColorStack Slack. Like low key, like even today, Tomas said, "Oh, O3, the new OpenAI model just dropped. Whoa, that's crazy." And then that prompts me to open up Twitter, and then I see all this talk on my timeline. So the ColorStack Slack, honestly, my vision for it in the future is that it's this very technical place, especially for alumni. Obviously undergrad is maybe a little bit of a different experience, but like especially for alumni, we should be just actively talking about the newest things that are out, and how to best utilize them. So I'd say that's a big one. Um, let's see if we got some more questions. That was a good question, Jared. Thank you. Um, let's see. Uh, I like this one. Hold on. How do I bring this? Dang, whoever was bringing these questions to the stage, can you help me out again? I don't For some reason I don't know how to post this one. Hold on, give me 1 second, guys. How do I bring this to the stage, bro? Okay, well I'll just read out questions and answer them. Caleb or somebody else, if you could help bring questions to the stage, that'd be great. Plans for Oyster. I'll just quickly touch on plans for Oyster. Um, so in terms of some new features that are coming up pretty soon, one thing that we're actively talking about right now is mentorship. That's something that a lot of members have asked about pretty much in the last couple of years, to be honest. And so I think we're at a point we've done some experiments with program specific mentorship. So we did a program with Bloomberg, where Bloomberg engineers were mentoring ColorStack members. That went really well. And by the way, like once you guys are actually alumni, one thing you'll learn is that a lot of these companies will actually donate money to the organization that their employees volunteer with. So for example, in the Bloomberg case, there's all these people that are volunteering, and literally there's a ColorStack alumni from Bloomberg that I think volunteered something like 50 hours for the year, and we literally just got a $5,000 check from Bloomberg because they volunteered with ColorStack members. So mentorship is obviously big for us because mentorship, but it also like helps us be more fiscally sustainable as well. So that's definitely going to be something that's coming up in Q1. We just started those conversations. Tomas is going to be building that one out. We want to obviously take advantage of the ColorStack network. There's now people that have been 4 years in ColorStack and already want to give back. And so we're probably going to start internal, and then very soon after actually do external mentorship, where literally anybody in industry, if they see us and they want to help out, they'll be able to help out. So so that's that. um Talk about the next thing. What are the key challenges in implementing RAG effectively? This is important. I actually want to tie it to a question of what can we do to respect privacy and data. So oftentimes we need to actually like give it some additional data that helps ground the actual LLM response. We have to be careful about this, right? Because we obviously don't want any like PII data. So if there's ever anything that's identifying, we don't want to give that to the LLM. So like I'd say that's definitely the biggest way that we respect privacy. But at the same time, we also do need to give it enough data where it's actually coming up with something meaningful. So tying it back to the other question, key challenges, we want to make sure that we're giving it enough context that it knows what to do. Another thing generally, like with RAG, and this is not necessarily just RAG, this is also just like prompting in general. This is like kind of prompt engineering. It's one really effective method is actually giving it some examples of how to respond. So like in our case, when we were doing the Ask AI, we have an example of here's what a Slack message might look like, and here's how you should respond based on that response. And so that's definitely a very effective way to make sure that it's not yeah, just not tripping in general. And then like I said earlier, give it enough context so it doesn't hallucinate and it doesn't just provide guardrails for it effectively, which to be honest is not necessarily RAG specific. That's kind of just working with LLMs and prompt engineering in general. So yeah, that's that. um Future base. Yeah, hopefully we can definitely have more tech talks in the future. I think that's something we're going to try to incorporate. I know there's been an idea as well of like can we do like live streaming of some of us building features out in real time. That's definitely a good idea. We'll think about that. I'm not in my like streamer era or anything like that, so like we'll see what that's like. I don't know if I got the streaming set up, but maybe we could do that in a low stakes way. So I like that question. What projects do you recommend to learn and implement RAG? I don't recommend any project other than the one you're building for the winter break hackathon. Build something. That's literally the way that you're gonna learn it. Literally, I'll share this file. It's just I kind of just like published it kind of randomly on this random branch in our repository. But feel free to look at that. But like don't go to any project to learn it. Like literally just build it. And if you need to use tools like an LLM or whatever to assist you in that, feel free to 100%. I'm a big proponent of using those as tools for your learning. Just build it. Don't try to quote unquote learn too much by reading or doing some course or anything. Literally just build it. It's not as crazy as you think. So yeah. um let's see. There's a few more questions. Let's see what we can. Uh, um, is there documentation I could read on ColorStack's RAG implementation? Um, I don't know if there's any documentation. I mean, I try to document inline, in the code base as much as possible. I don't think there's any super high level documentation on how we built the RAG system. But again, it is a fairly generic formula in terms of it's really the retrieval step that's the important one. So hopefully, I'll share this piece of code. Actually, matter of fact, I'll just link it right now. So hopefully that's helpful. But again, it's a fairly generic formula in terms of building a RAG system. So don't overthink it too much. LOL, I just put that in the FAQ. Look at me, I'm not following rules. Here we go. So yeah, don't overthink it too much. Again, just build. Hopefully that should help. Okay, let's see. The tech Twitter accounts that I follow in Slack. Yeah. I could definitely find some of those main accounts. Yeah, Kelly, I got you after. Um, yeah. Let's see what other. Yeah, just in general, somebody asked like, how do you prevent hallucination and just improving the quality of the responses. Again, the more context you give it, that's very important. The second thing again is when it comes to prompt engineering in general, giving it examples is a very effective way to make sure the LLM is doing what you want it to do. So that's a big one. Um, how can we scale these applications to large systems? That's a great question. I actually don't know. I'm not 100% sure. There's, obviously this is a fairly limited, scope for us in terms of we're never gonna have more than well, actually, let me not even say that. Currently, we have 15,000 members, so it's obviously we're not dealing with the billion space or anything like that. Um, I would say I think some of these underlying technologies do scale very well. So things like Pinecone and some of these other specialized tools, I think they kind of have scale integrated just in the fabric of yeah, just everything they do. So I would imagine that whatever these tools that we're using, that if we were on for example, the enterprise plan, I imagine it'd scale pretty well. So yeah, I don't think that's too big of a concern. Um, what are the questions we got here? No, you cannot build a feature for Oyster winter break hackathon. We want you to build your own projects. We don't want you to use Oyster as that. Go if you had an idea for building something, we want you to build it. Like that's the main thing that we want to get out of this. Like you identified a problem on your campus or in your life or in somebody else's life, like go build it. Like like we want to support you in that process. Less of contributing to Oyster. So that's that. Um, yeah. So another security question again. Yeah, I think the important thing is just making sure that we're not leaking any sensitive data to the LLM. That's the important piece. So we're not again. Yeah, that's definitely the main one. Yeah, will Liverpool win the Prem and the Champions League? 100%. That's my favorite question. They're 100% winning the league. How long do I see myself leading ColorStack Oyster? That's a great question. Honestly, I mean that could be very variable. A lot of what Duran and I have talked about is we want to build the foundation for ColorStack engineering, and I think we've done a pretty good job at that. And now it's just about how do we make that process a little bit less dependent on myself. So obviously there's a lot of talent in the community, and so yeah, who knows? Maybe we'll start to think about hiring in the next 6 months or so. So we'll see. Alrighty, one last question. Let's go. One last question. I think I got a lot of the upvoted ones. Let's see. What are the best strategies for a beginner to effectively prepare for and participate in a hackathon? Honestly, this isn't just my personal advice. I wouldn't say this is like the best advice or anything, but genuinely, like from a hackathon, I'm just looking for you to learn. Like that's like the whole prize thing is, some people just need prizes and stuff to participate. I literally don't care about any of the prizes. I don't even care about the winners. Sorry to say, like if you're like super invested in that, I personally am not that invested. Like my hope for each one of you guys is that you learn something new and then you have fun in the process of building something. So I wouldn't stress too much. I would literally just think about what you want to build and give it a shot. Like that's literally it. I wouldn't try to go research like, oh, how to be the best hackathon participant or anything like that. Like we're also doing it in a different way. This is not like a 1-day hackathon or a 2-day hackathon where like you got to be extremely locked in. We understand that over winter break, you're kicking it with fam and all that type of stuff. So just have fun in that process. Okay, guys, I think that's probably the last question, but I appreciate you all. Again, I hope you all participate in this hackathon. I hope you learned something new today as well. Hopefully, it wasn't too daunting. Hopefully, I explained things in a simple way. If not, let me know. We can follow up and I can answer any questions. But appreciate you all and hope you have a beautiful winter break.
Yes, thank you so much, Rami. Oh my gosh, y'all, let's give Rami all the love in the chat as well as in the emojis.
Thank you. Thank you.
Period. Have a happy holiday
Thank you.
and a
Thank you.
happy new year.
Yeah.
All right, y'all, we're gonna go ahead and get into the giveaway question. Are y'all ready? Okay, the giveaway question is, what are vectors that represent real world objects like words, images, and videos? What are vectors that represent real world objects like words, images, or videos? Alrighty, we do have a winner. The winner is Isaac. Isaac, the answer was embeddings, y'all. Embeddings. Y'all, thank you so much. The giveaway winner, you will be reached out to by the ColorStack team next week, talking about your gift. And with that, y'all, this is our last. We are at the end of our Fam Friday for December. I cannot believe it, y'all. I have been with y'all. If y'all were here from my first one, I've been here for like 2 years now. This is so amazing. I love what ColorStack does. ColorStack really is investing in our communities, and I'm just so proud and honored to be a part of this team. The team working behind the scenes is so working so hard, and I'm hoping y'all are super grateful and really taking in this information and coming into these sessions with intention and wanting to grow your community, y'all. Congratulations on making it all the way to the end of today. I know it's probably cold, but you made it. You showed up for yourself. You showed up for your future self. And look at you. Look at you. Look at you. I'm so proud of you. Y'all, congratulations again on finishing your fall semester. And for those who graduated, we're incredibly proud of you as well. Congratulations. We won't see you in January for Fan Friday, but mark your calendars. The spring virtual career fair is on January 24th. 2025, and we'll be back with Fan Friday in February. Don't forget to fill out the survey pinned in the chat. We absolutely value your feedback. And giveaway winners will be emailed by the second week of January, if not sooner. As a heads up, the ColorStack offices go on winter break starting tomorrow and will return on January 6th. Join the winter break hackathon and remember to check Slack for details. Wow. Wow, y'all. Once again, make sure to follow ColorStack on all social medias. I'm talking Twitter at ColorStack.org, Instagram at ColorStack.org, LinkedIn at ColorStack, their website as well. Make sure to follow me, Michelle Adana, on Instagram and TikTok. Get your merch, divas. Let's start 2025 with merch so we could twin. What? So we could all like twin. What? I'm wishing you all a safe and restful winter break. Happy holidays to those who celebrate, and a wonderful new year. I will see you in 2025, recharged and ready to go. Y'all stay warm, stay curious, be kind to yourself, keep being amazing. Thank you for joining us. I'll see y'all. Bye. Oh my gosh. Bye.